back and forth between exponents and logs and how they relate. So we're going to look at the definition right here. So I have b as the base raised to the power of x exponent equals a, the argument. So then I know the base will always be the base. So base b right there of a, the argument, equals x, the exponent. How do you read this? Well, you read log base b of a equals x. So you read log base b of a equals x. Log base b of a equals x. All right. Why do we do this? Well, to isolate x. So we will solve equations right here to where the unknown is in the exponent. And then you're going to have to use logs to do that. So to isolate the exponent. Okay, so right here, we're going to rewrite from the exponential to the logarithmic. Base is always the base. So you have log base 7. What's the argument? 49 equals x, the exponent. Again, log, what's the base here? Base 3 of what? Argument 243 equals the exponent 5. Now, don't get scared with fractions and negatives. It's fine. So log base 6 of the argument 1 over 36 equals the exponent negative 2. Log base 9 of 27 equals 1.5. Log base 4 of what? X is 9. Log base 2 of 20 equals x. Log base 8 of 32 equals x. Notice we have a lot of examples on this one. And now we're going to go backwards. Base is always the base. So this is the base. So base 2, x is the exponent, equals 64, or the argument. Again, x is the base, because that's the base right there. Log base x of 64 is 2. Therefore, x to the power of 2, or the exponent is 2, equals 64. I want to stop here for a second. When you look at this, what squared give you 64? And we will use these properties right here to help you solve for x. Base 64 to the exponent 2 equals the argument x. Now, common log uses base of 10. So notice that this one, I don't have a base. Well, when you don't have a base, the default is base 10. Okay, there's an invisible 10 right there. There's no need to write. So base 10 to the power of 2 equals 100. Because you know 10 squared is 100. So base 10, again, when you don't have anything, the base is 10. So 10 to the exponent of -3 equals x. Now we're still doing it. Base 10 to the 4th power equals 10,000. 10 to what exponent is 1 over 10? Okay, pause here for a second. Try to figure this out. What does negative exponent mean? To give you the reciprocal right there. Okay, I want to leave you with a note, because I think when you're working this out, you will find something else that you need to know is when you have log with base e of x is the same thing as natural log of x. Now, natural log is different than common log. Okay, the common log, the base is 10. The natural log, the base is e. Okay, and the way they relate, if you have natural log of when the argument is e to the power of x, then that equals x. And we will cover this a little bit more, and you'll understand why when we cover properties of logs. And this is also true when you have e to the power of natural log x, that also equals x. Again, we will cover the fine print of this and why this makes sense by